Now let's look at an example. Find the equations of the vertical asymptotes of the following function. From this function, we can see that we don't have natural logarithm, so we don't need to consider anything about that, but we do have a denominator here. And as I mentioned in the concept video, when the denominator equals to 0, those x will be my candidate for a vertical asymptote. So let's write that down. Now, we need to solve this equation. Notice that the first term, e to the power of x, is strictly greater than 0, because the graph looks like this. We can see that it never crosses the x-axis, and it's greater than 0. In other words, in order for this equation to hold, I need those two terms to be 0. Now let's solve those two equations. The first one will give us x equals to 1. And the second equation, you can factor out x. You would get x times x squared minus 1 equals to 0. So that's when x equals to 0, or let's write that down, or x times x squared minus 1 equals to 0. That's one, which implies x equals to 0, or x equals to plus or minus 1. So now we have three candidates. X equals to 0, x equals to 1, and the other one is x equals to -1. As we mentioned before, those are just candidates, so now let's check if they're actually my vertical asymptote. To do that, we need to check as my f of x approach those 3 points, is my limit infinity. Let's do the first one. Limit as x approach to 1 of my f of x. Before I do anything, let's see if we can simplify this fraction first. I can see that for the top I can factor out 1x here, and for the bottom I can factor out 1x here as well, so maybe they will cancel out. I have x times -x plus 1 times x minus 2 over e to the x minus 1 times x squared minus 1. Now we can cancel out some terms. X and x cancelled out. 1 minus x and x minus 1, so this term and this term, they're negative of each other, so we can cancel them out and left with a minus 1. So finally, my limit becomes negative x minus 2 over e to the power of x times x squared minus 1. Now, if I plug in 1 inside of my function, top is a constant, so top will be -1 minus 2, which is a positive number, but bottom is still going to be 0. So this is a constant over 0 case. Let's write it right here in a small box. When we have a constant over 0 case, we know that the limit is either plus or minus infinity. And in this case, we need to discuss the one-sided limit. So instead of 1, I need to check as x approach 1 from the left and 1 from the right. Let's do 1 from the right first. Let's add plus here and plus here. So let's check this part. If I plug in 1 from the right, I can see that the top will be -1 minus 2. This is negative, 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 which is going to be positive. So the top will be plus 1, a positive number. And the bottom, because I'm approaching 1 from the right hand side, which means my x is slightly bigger than 1. In other words, x squared is also going to be slightly bigger than 1, and x squared minus 1 should be greater than 0. So my bottom is actually approaching 0 from the positive side. Now I have a positive number over a positive number. That's going to give me a positive number, and we know that it's either plus or minus infinity. So in this case, we would get plus infinity. And as we mentioned before, as long as I have one side limit equals to infinity or negative infinity, that means we have a vertical asymptote. So this tells us x equals to 1 is a vertical asymptote. Now let's check when x equals to 0. Consider the limit x approach to 0 of f of x. Now I'm gonna go strictly to after the simplification. So that's gonna be x approach to 0 of negative x minus 2 over e to the power of x times x squared minus 1. If we plug in this 0, you'll see that top we have a constant, negative 0 minus 2, which is 2. Bottom, you also have a constant. In this case, it's the easiest case. You have a constant directly. There is no dividing by 0. We can just plug in the number and get to the final result. So that's going to be negative 0 minus 2 over e to the 0 times 0 minus 1. That's 2 over negative 1, which is negative 2. And because the limit is not infinity or negative infinity, x equals to 0 is not a vertical asymptote. And lastly, we need to check when x equals to negative 1. Again, let's check the limit and go directly to the simplified version. Now let's plug in negative 1 again. The top you would have negative 1, negative 2, here is negative 3, so top will be 3. And bottom, here will be 0. So again, we would have a constant over 0 case. It's plus or minus infinity, which means I need to discuss the one-sided limit. Here, again, you can do positive side or negative side, it does not matter. So let's do, because last time we did negative side, so let's do, we did positive side last time. Let's do negative side this time. So add a minus here. Let's consider this one. I have x is less than negative 1. Because it's a negative number, we need to be more careful. X is less than negative 1. If I square both sides, because it's a negative number, I need to change the sign. So x squared is actually greater than 1. So x squared minus 1 should be greater than 0. Because it's greater than 0 here, we know that, well, again, I'm approaching 0 from the positive side. That means top, I have a positive number. Bottom, I have a positive number. So overall, it's going to be positive again. And because we know it's plus or minus infinity, it's going to be positive infinity. Just like last time. Again, since one-sided limit equals to infinity already, we know that it is a vertical asymptote. So therefore, so x equals to negative 1 is also a vertical asymptote. Let me read this part. Therefore, we have two vertical asymptotes. One is at x equals to 1, and the other one is at x equals to negative 1. That's this question.